All right. Hello, everyone. My name is Andre Diaz. I'm here with my project partner, Leon Jin. We are going to be going over our code. This is the code review. Um, so I wanted to start off with we're looking at the Ocular application.java file. So we did Spring Boot. So we got some annotations over here for Spring Boot. I have scheduling enabled because I have some tasks that we will take a look at a later point of this video. Um, so this logger factory is what we use for our logs. I can give you a little sneak peek at that. So this is some of our logs from a recent log file. So some of these are from the Spring Boot application infrastructure. Some of the stuff is our logs that I added. So, for example, the metrics collector started, new cycle, system tray is added. So, a lot of these infos, there are errors. We don't like to see errors. So, it's a good thing that we don't see them in here. They come up if an exception was caught, which we'll take a look at in a little bit. So once Spring Boot starts the Ocular application class, after that's constructed, it'll start this metrics collection, which takes this metrics collector object and calls the start collecting metrics method. So once that happens, I log that the metrics collector started, and then I also create the system tray, which you'll see during the code demonstration video. That's just essentially a an icon that'll pop up over here with the Ocular logo, where you can actually exit out of the application. So I have some beans over here. That's just a Spring Boot thing so that it can aid in the injection of these objects at other places. That's that icon, the system tray that I was talking about. You can right click on it. Um, so our folder structure on the left hand side over here, we're going to start looking at some tables. These are your database objects. You have to annotate them with the entity annotation. Uh, this ID says that this ID field is the primary key for this table. Now, this CPU object represents a data table in our SQLite database. Uh, each one of these fields that you see over here um, is a field inside of the database, except for this formatted time that's been annotated with transient so that it does not go into the database. Um, so this sort of pattern, then of course you have your getters and setters, but we've already seen those. This sort of pattern is replicated amongst all of these objects to represent the different data tables in our database. Um, Inside of the tables folder, I also included the CPU repository and the repository for the rest of the data tables, the memory, process, and users. We can take a look at the CPU repository. This uses the Spring Boot JPA repository annotation. Um, and this is an interface. So this interface is used throughout the Spring Boot application. This is what we use to perform our CRUD operations. So from here, because I specified the object type of CPU and the primary key associated with that, we can extend JPA repository through that entity object. Now, Spring is pretty cool. It'll actually allow you to create queries through the method name. Um, so, for instance, this will return this. If I call this method, it'll return a CPU object, and it's find by date time. So I have to give it a date time object, and it'll find a CPU object that matches that date time if it's there. So some of the ones that is pretty useful is this find by date time before. So given a date time, it'll return a list of CPU objects or tuples inside of the database that's were collected prior to this time. So this sort of model is again followed in the memory repository, where we have the same sort of annotations, extends the JPA repository, and specifying the memory object and that the primary key is a long, and then have different types of queries for memory. Uh, Same deal here for process repository, for the process table. And these interact specifically with these entity objects, the repository and the entity. They go hand in hand. So we can go ahead and look at the CPU collector. CPU collectors inside of this metrics collection folder. We're going to start off with the metrics collector because that's where everything spawns from. So, like I pointed out earlier, Ocular application, our main, after it's constructed, will actually call the start collecting metrics method of our metrics collector. So this metrics collector object is created. Then we call the start collecting metrics object. It'll create a timer. That timer runs at it calls like the scheduled fixed rate. So essentially what we're doing here is we're just creating a scheduled task, right? Like this timer is going to execute every pole speed times 1,000, so that we can get it in milliseconds. So currently we're collecting data every 5 seconds. That's our pole speed up here. And it's just going to over and over again call collect and save metrics. Collect and save metrics is where we actually call our collection methods for our CPU, memory, and process. And that's where we get this log that says new cycle. We also have this method over here, this stop collecting metrics method. This is actually called when you right click on that icon and hit exit. That'll actually stop the metrics collector first before, so that it has time to save any remaining data before it actually stops the application. So we can go and look at the CPU collector. So this is where we're collecting our CPU data from our PC. We have some private variables up at the top. Cleanup cycle we'll talk about in a little bit. We have our loggers so we can capture any errors that occur while we're collecting the CPU data. CPU repository is where we're going to be actually saving our newly created or collected data in our database. That's that object that we just looked at before, which allows us to query the database, but also perform other CRUD operations and save and delete records. So these other fields are what we use to actually get the CPU data. So we'll take a look at that. So from the metrics collector, we call this collect and save metrics method. This is going to go through and create a CPU object. That CPU object is going to be used, and we're going to call the setter for each of the relevant fields. So for the data that we're collecting from the PC. So for date time, we're going to collect the moment that the data was collected. We're going to call the get processor model method, the processor speed, etc., for each one of these fields. So once that happens, we're going to call our CPU repository. We're going to call the save method and pass it this CPU object. And this entity object, it's going to be able to interpret it and ensure that it goes into the proper columns of a new record, a new tuple for this table, for the CPU table. So we can just briefly look at the idea here behind each one of these methods that or functions that we're calling to return the information collected from the PC. We're using try catches in here if there is any sort of exception while it is trying to get the relevant data point, then that exception will be logged, and we'll also get this error retrieving, which will specify where the error is occurring in terms of what data point it's trying to collect. So that is just replicated all among these different data points. At the end over here, we have this at scheduled annotation. Now, this is being used for this cleanup method. Each one of these collectors has a cleanup method that is being run on a scheduled uh, event, which we're going to talk about right here. The idea here is that over time, the database will continue to grow and as it collects more and more data. The idea here is to decide at what point is data no longer relevant. And once that happens, that data is deleted to ensure that you have the most recent information as well as some temporal nature to it in terms of history, but that it's not collecting data for 6 years. So over here, this at scheduled annotation accepts this argument in here where I'm setting the fixed delay, which is the amount of time that it's going to wait before it runs this method. Um, and over here, we're waiting. So what I did is the metrics collector pull speed of 5 seconds, multiplying it by 1,000 to turn that into milliseconds. And I want to call this cleanup. I want to clean old CPU data after every 30 cycles. Now, on top of that, when I create this threshold time, which is the time in the past that any data older than that is going to be deleted, I created this cleanup cycle static field and set it equal to 200. Because I want to keep 200 records in the database at all times. Now, this can be changed simply by modifying this value up here. I thought 200 was okay for now. So what's going to happen is it's going to look at 200 cycles times the pull speed to determine how far in the past is the cutoff point. And then we're going to use the CPU repository object and we're going to query it with that find by date time before that we mentioned that we talked about previously with the threshold time. And that's going to give us a list of CPU records that are considered old and are allowed to be deleted. Once that happens, we're going to call CPU repository and delete all, which is a base method of this object, and pass it the list of old CPU data. And then we're going to say CPU table cleanup was completed. So this idea here is replicated in the memory where we have where we create the memory object, where we use the setters to set all the relevant data points for that memory hardware. And then we save it using the repository, using try catches to make sure that any sort of errors are logged. And it can be understood of like what exactly is causing the problem. Maybe there's a hardware compatibility issue, or that hardware just doesn't have that information. And then followed by a scheduled task down there to clean up old memory data, where again, we use this cleanup cycle of 200 times that by the pull speed of 5 seconds, and anything older than 200 cycles in the past can be deleted and discarded. So, process, same idea. What's interesting with process is that you actually collect the list of process. It's not just a snapshot of singular data points and like 5 to 10 of them all in one shot, right? It could be like 100 process that are running on your PC. So because of that, you actually have to we're using like a for loop to go through each one of those processes, gathering the relevant data from each one of those process, creating that process object, setting everything again, and then saving it. Uh, and if there's any sort of error, then we can log that uh, and provide useful information on what the problem is. And then again, we're going to clean up data. So because the process is, we're more so curious about the recent current snapshot. I decided that probably wasn't a good idea to wait and store old data for a long time when it's essentially useless after we collect the next data point. So I set the fixed delay to 2 cycles, so that it calls this method every 2 cycles. And I'm also going to delete anything older than 2 cycles, because that's what my threshold time is down here, which we're going to use this find by date time before method, and delete any of the processes that are older than that. So uh, you can see over here that these logs show that it's been successful, or at least it ran through it and was able to print the logs without any errors. Um, and the CPU, memory, and process table cleanups have been completed. Next, we're going to talk about the CPU service and the controller with Leon. I just want to briefly talk about logback spring XML. This is our configuration file for our logs. We have a console appender, which is helping us during our debugging, so we can actually see the logs in our console environment. But then we also are printing it out to a file. That file location is going to be inside of app data roaming ocular logs. We also have like the test files down here, but we've already discussed that in a previous video. And yeah, all right. Leon, you want to
Yeah, thank you. Would you
take
mind?
over?
Yeah, let me share my screen. Quick. Can you see the screen?
Yeah. Sorry.
Okay. So my partner Andre Diaz, like his job is more like focus on the back end and the database. For me, it's more like a front end and like a API. So let's go through from let's begin at like from a controller. So as we know, like for the Spring Boot like application, we need like a controller and a service. And for a controller, it's more like to handle the HTTP request and give the response. And the service is more like to handle the business logic. So let's go take a look at like a CPU controller first. So as you see right here, like we have the annotation REST controller and we have the REST map request mapping. We have the reference from the CPU service and also the auto wire, like right here, the annotation for the constructor. So we try to get we have the get mapping right here. Basically, we try to like right here was like for this part actually it's like we're gonna return the CPU list, but also before we have some issue about to displaying to fetch uh the about the uptime for the processor uptime. We do have that issue before. So right here, like, what I did right here is like to calculate the formatted uptime and like set the formatted uptime in the CPU object and return back to the CPU. And for the right here for the post mapping, get mapping, put mapping, delete mapping, all these annotations for the CRUD operations to run like to get, update, sorry, get, add, update, and delete these functions. For the memory controller is basically like a same like how we did like in the CPU controller. We also have like yeah we have like a local operation right here for the HTTP status created because I want to emphasize oh just like I want to emphasize like the response code to be a 201 instead of like 200. Okay. So for the process controller, as you see right here, still pretty much same as what we did in the previous like two controller. And then like we have like the things like instead of like ID for the process, we have the PID. Yeah, and this is like the CRUD operations. For the service, let me go get a CPU service first. So right here, we can try to get the CPU list, and like also we try to get the CPU by the ID. We add like this also right here is like add CPU, update CPU, and delete CPU right here. We want to make sure like the updating is like the existing CPU will be the newest one. So that's why I say right here, oh, we're gonna go through all the list there to find like oh set the new information, set the new like new processor type, new speed, like a new usage and new count, new setup time for that for the existing CPU. And like we also will return this back to the we're gonna save that. We're gonna return back to CPU repository, we're gonna save that to our database. For a memory service is basically pretty much we did that before. Yes, I'd like to mention about like for the all the service actually we do have the optional right here. For the optional, it's more like to check is that like is included or no. Like for example, right here we basically are make sure like optional we check like oh we can make sure like the memory ID like is actually in the memory. And for the for all the like deletes right here, the business logic for the deletes, we have like we set as like a boolean. When it's like so when we find like oh if the ideas exist, then okay we can delete that. Then we're gonna return to the true statements. If it's not, then gonna return to the false. So for a process service, basically it's pretty much exactly same as what we did for the previous two surveys. Yes, and you see right here, like we have a map to go through all the like to go through all the process in our database and try to and find it by the ID. So right now let's talk about the front end. So for the front end, we have after we're creating the APIs, we need to fetch the APIs. So we have the fetch CPU, fetch memory, fetch process. For the fetch CPU, as you see right here, this is just like a global variables because we want to create. So basically, in our Ocular application, we have 4 charts, 2 God chart and two gauge chart and like a 2 line chart. Um, so as you see right here, like for the charts, we like right here we can see you have like global variables for the charts, and then we have like the usage for the process and the line and for the CPU usage, just for a line chart, and also have the CPU use color and the CPU free color for the God chart. Um, so right here we have a function to fetch the CPU, and like after the fetch, we're gonna respond to the JSON, and like also we're gonna show this CPU array right here. We want to examine the raw data to make sure it's no return like a no. And also we right here you see we sort away by the data time probably in this order. We want to make sure the order is correct. If the order is not correct, probably it won't return a value properly. And also we want to fetch the latest CPU records because we want to make sure like our basically like we when we're fetching the data is updating every 5 seconds, so definitely you don't want to like keep your old data. You want to get the newest one. And so right here is like how we do the for the charts, for the CPU charts. So for the CPU chart, uh we have the 2 chart for the CPU. One is the line charts, and another is a God chart, as I mentioned before for the CPU. Right here we gonna clear and update. Right here, basically, we want to clear and update CPU list elements. Want to clear what I got before. So right here, this is like clear that, and we can go through all the CPU list elements to print out all the list. So you see right here the print line. Basically is the style, and we have like list CPU item dot text contents. We're gonna show like all the information we just fetched from the API. And also after that, we're gonna add the new list item to the list elements. So right here, as you see, that's the features like in the early demo we showed it before. We have like the processor usage color, like the colors. So the colors will change based on the CPU usage. So when the usage is between 0 and 50, it's gonna be the green. When it's more than like a 50, between 50 and 80, it's gonna turn to color yellow, and it's like with between 80 and 99, it's gonna turn to color red. And we have the else statement right here to console.arrow to show just in case, if the CPU percentage, like what we fetched, is like it's not in the range. So it's help us to debug all the things. And also right here, we have the chart element right here for our CPU. And we'll make sure that we want to make sure that is that successfully set this up. And if it's not set up, like if you cannot find that, then we're gonna just like create a one. We can define the data for the chart. And as you see right here, we have the data set. Right. For all the chart we use, basically we're using the chart.js. It's really chart.js. This library is pretty powerful. It's like support us to visualize all the data into the chart. So we have the data sets right here. We have this is like a CPU usage, and this is like 100 minus, this is like a free usage. For also, yeah, right here, create a chart if it doesn't exist right here. We create a donut charts because the chart.js actually they don't really like sports the half like don't really support the got like a gauge chart. So what I did is like I just cut in the half. Like right here, we do the rotation minus like 90 and circumference like 180. And after everything, so we want to update that. We want to update the existing color and the chart. So this is all information we update that. Same as the line chart, how we do that right here. We get the data and we set up, define the data for a line chart and create a line chart. And right here we want to remove all this data with more than 10 items because for the line charts, if you use the more than 10 seconds for the for displaying, we want to do that. We want to remove like the first one, the first item. So we use like line chart data, then data sets like 0 data the shift. This allow us to remove the first data since like if the length is bigger than the length is like more than 10, then we update that. Then we have the console arrow right here to show what happened if a line like will show that like the line chart element is not found. This can help us to debug that. Also, we have the catch arrow right here. So that's how we do for fetch CPU, for the fetch memory right here. Basically, we do the same things right here. We set up the colors for all these global variables, and also we set a function to fetch memory data and update the chart. Um, for yes, this is basically same for the chart. The only difference like the object what we fetch is like a memory, is no CPU. And for the yes, I also like to mention about this one, the chart like updates. If you don't trigger the re-rendering, the issue gonna be cause is like the chart is not updating, the color is not updating. It's gonna cause like actually an issue. And yes, they're basically pretty same. For the okay, let's move to the fetch process. Actually, for the fetch process is kind of different. As we see right here, like is we got like multiple functions. So as we know before, like if you go check the task manager on the Windows, you'll see like the process. Each of them sometimes like they have like subtask. For example, like for example the browser, the Chrome browser is have like a bunch of like also like a subtask under the main one. So that's why we have like a parent ID. So look at this. We're gonna go through all process first. We're gonna fetch by get an ID and go through everything first. And like if the parent ID doesn't exist, then we're gonna initialize it. And also we're gonna add the current process to the parents group. Then we'll return back to the return to the group process. Right here, this function is like to display the group process in the container. So basically, all the process list will be in this container, and we'll get all the parent ID, and like we just go go loop like each group by parent ID, and we get a list of the process for the parent ID, and like create a section for each parent ID. So that's what you see right here, parent section dot class name equal to process group. And we want to add a heading to indicate the parent ID. So it's right here, as you see, it's like parent ID. And this is a list process that basically will be basically is kind of like inside of a container. And right here, we're gonna just like populate the process list for each parent ID. And like you see, we have like PID, name, CPU usage, and the memory usage. And we're gonna add a list to the parent section and add the parent section to the container. So basically they are like a link. It's kind of like they're linked together. So right here is the fetch process. Like we're gonna fetch the process from the API as we see right here. And like we have the catch arrow. And then as we see right here, like we have the process like a list container, and we can group the process by parent ID, and also we can display that and display the ground process group data like process in a container. Like, I would like to mention about like ensure about this part because we want to make sure like the DOM has fully loaded when we call that. So this is necessary to add it right here, just in case. Let me show the index.html file right here. So this is the front end. We have the body. This is the color, and this is the basic like CSS for the yeah, basic CSS for our like main page. And as you see, we have a accordion, we have like a chart size, like this is the top navigation bar we have. And also we use a chart.js. This is the source we're gonna use. Um, right now it's working to the Ocular. This is the top nav bar, and as you see, we get like 4 buttons right here. We can go to home, GitHub about Ocular and like log in. And so right here is like a more like we like to because like we have like accordion, so we want to display that in that like in that. So we have like all information right here, and then we're gonna in the first one, we're gonna display the memory usage charge and the CPU usage chart. For a second, we're gonna display the memory line chart, CPU line chart. Then in the end, we're gonna display the process. Yep, we are gonna like display that, and 100% don't forget to like include your resource, your file. So right here, the function, this one is like we use the JavaScript to make the make all the accordions like clickable and like makes it works. This is how we do the animation for that. We make sure it's like when user like first time like get it into the main page and all the like accordions like close, but only when you click that it will be open. And then as you see right here, we fetch the data from the user API. You see, and like we set like interval, like we set up like every 5 seconds to fetch them. Yeah, that's basically how we do that. Also I'd like to mention about about our database. Before we have some problem to displaying the CPU processor update time, especially like when me and my partner like work separately. So we found out the issue that's like we collect the update time by seconds, and like the data type is like long. So in order to convert that to be to a string, so we use as I showed before in my CPU CPU service. No, I mean CPU controller, I think. Yes, you know, CPU controller right here. So we use the formats like this one, and this one can is also like a dependency, I do believe, and this can help us to convert like the time to be the day and like hours and seconds, minutes and seconds, and that's how we do that to convert the time. And like we didn't really physically to store the formatted uptime because we just want to display that, so we didn't really store that in our database. And as you see right here, and we can, yeah, and we successfully can display that. Andre, would you mind to talk a little bit more about our dependencies?
Yeah.
Okay.
So I'm going to talk about the POM XML, which is what Maven uses to build our project, and the application properties, which is found underneath the resources. So, application properties has some essential configuration properties for our database. So, we specified the application name. Over here, the data source, which is using SQLite, and I'm calling the database ocular.db, and that database is going to be made inside of the root directory of the program. Um, for wherever you it's installed. You have to supply it the driver, and then there's some additional properties for connection test query, and the dialect, so that Spring Boot's JPA infrastructure knows how to uh, communicate specifically in SQLite to create the database and either query information or send information back and forth. Um, so that is the application properties.
Mhm.
The POM XML file is for Maven. So when every time there are changes to the project and we want to create an executable, you can right click on Maven down here. Maven actually, this is a plugin for VS Code, and it shows us different plugins that we have all throughout this POM XML file and the dependencies that we're using throughout our project. So we can look at that and see that for starters, we're using the Spring Boot starter data JPA, which is what we're using to talk to the SQLite database and store the information and query it. We're also using the starter web uh, repository dependency, which is more so for the front end REST API. We have the SQLite driver, the dialects for JPA to SQLite, a test dependency for our unit tests, the Oshi core, which is what we're using for most of our data collection from the physical machine, and then some JNA for there's a couple spots where we're doing some specific queries for machine information that requires JNA instructions. So this Maven file has all these dependencies listed between these tags. It's an XML file, so it's in that format. We're specifying Java version 17, and we're using Maven to compile it at that version as well. We can scroll down and see the build, which provides some information on what it should be doing uh, during the build to package it. So we're using the Spring Boot Maven plugin, which is going to actually repackage it into a jar that can handle, or a jar specific to the Spring Boot format. So once that happens, we actually use this other application called I know setup. So in here, I have some configuration information for the setup, where to install, or I guess where to copy, which we're copying the target folder, and where to actually save it. And we're doing this with an icon as well. So this actually creates the installer. So every single time there's a change, gotta highlight this, generate a new GUID. We're gonna compile it with all these settings. I add some stuff to make it run on startup. Once this is completed, it says finished, and we can see inside our directory we have this Ocular setup exe.
Okay, thank you. I think that's all for our code review section.
Thank you
Okay.
so much.